SmartTouch, a new haptic AR system to touch the non-touchable. In previous sessions of SIGGRAPH, the Tachi laboratory has proposed novel methods for the augmented reality of haptics, such as the Smart Tool in 2001 and the Smart Finger in 2002. We present this year a new type of haptic AR system, the SmartTouch. We have been developing a tactile display to present realistic skin sensation for virtual reality. The idea is to selectively stimulate each kind of receptor in the skin and to reconstruct complex tactile sensations by combining these stimuli. We call them tactile primary colors, analogous to the three primary colors for vision. Our approach uses electrical stimulation through the skin or electrotactile display. Electrical current from surface electrodes generates an electric field inside the skin which induces nerve activity. We've shown that selective stimulation is possible through electrotactile display. The basic idea is to utilize the different placement of sensory nerves and to control the electric field by changing the current source distribution on the skin surface. Our first application was an electric mouse composed of 64 electrodes arranged on the button of a conventional mouse. At any instant, only one electrode serves as a stimulation electrode while the others are grounded. To present texture patterns, a time division raster scan was applied. The user can feel two-dimensional surface information through the finger. Since the electrotactile display essentially requires only electrodes on the skin, it can be made quite thin and small. This leads to a new application area of tactile display, the SmartTouch. The SmartTouch is composed of a thin electrotactile display and a sensor mounted on the skin. The sensory information is converted to tactile sensation through electrical stimulation. Thus, the wearer not only can make physical contact with the object, but also touch surface information of any modality, even those that are ordinarily non-touchable. This is a prototype of the SmartTouch. The top layer has a 4x4 array of stimulating electrodes on the front side of a thin plate, while the bottom layer has optical sensors on the reverse side of the plate. Visual images captured by the sensor are translated into tactile information and displayed through electrical stimulation. Using our primary color approach, we endeavored to realize the perception of luminance information as the unevenness of the object's surface by imitating the sensory nerve activity with electrical pulses. This video shows an experiment of the prototype SmartTouch with a visually impaired participant. The use of SmartTouch is not restricted to Braille. By changing the sensor, other modalities of sensation can be translated into touch as well. Our ultimate goal is to make the system negligibly thin so that it can be worn as an unconscious but essential daily interface, just like eyeglasses.